Okay. As Julian says, I work for Magnox, so as a senior consultant and intelligent customer. My background, for those of you who don't know, has been in radioanalytical chemistry for a number of years now, initially in the environmental arena, but latterly over the last 10 years with regards to low-level and ILW wastes. First of all, an apology. Those of you who know me know I tend to live out of a suitcase travelling around the country. So this presentation reflects a rather hurried, it's rather basic, and for that I apologise. And for those of you from Magnox, I promise I'll put the corporate livery in at a later date. Well, such things are very important, as we all know. So, where are we going from here? Well, let's look at the Magnox perspective first of all. It's a big job. Now, not to say Sellafield is not an equally big job, but it's challenging. This shows the dates when all these sites came offline. Wilver, we're hoping for 2014. Albury is actually coming offline this year. The 2020 vision, good, isn't it? I wonder how much we paid NDA for that. Is to achieve 8 out of 10 in some stage of care and maintenance. Obviously, to achieve this, we need a lot of characterization. The proposed idea is that we have an accelerated program at Bradwell and Tresfinid, a focused program to deliver passive care maintenance or interim care maintenance at Chapelcross and Dungeness, and steady as we go at the other sites. A lot of work in a very short time. The aspiration is that for Bradwell and Tresfinid, we achieve care maintenance in 2016. So, as the scope of decommission increases, the need for confident analysis also increases. Previous work, previous analysis has been about identifying the inventory, the nature of the waste to inform storage and movement around the site. Now that we're heavily into retrieval or demolition, we need to revisit those fingerprints to give us better accuracy for the purposes of disposition. Obviously, accreditation is increasingly important to assure confidence. But that will only happen in the nuclear waste industry when we have credible reference materials underpin the methodology. It's a point that was made not only by myself, but by other speakers at a recent Royal Society of Chemistry, Radiochemistry group seminar, a bit of a mouthful, which essentially says you can, no matter how well you manage an analytical process within the tenets of ISO 17025, as certified by UCAS, no matter how diligent your proficiency testing, and of course now we have MCerts to ensure a high degree of proficiency, certainty in radioactivity and water measurements or liquid measurements. Unless you've got reference material to underpin the entire analytical process, you really are on a slightly shaky foundation. Well, improved analytical competence, like smarter, right first time analysis. We can't afford the time or the money these days, as Ian quite rightly pointed out, to spend a lot of time over this. We need smart, right first time results. We need to extend accreditation to a wider range of radiochemical tests. We need to develop an expansion to waste matrices in particular. And this is all required to give the regulator greater confidence in what we do and the future condition of this waste over time. So we need spike reference materials, characterised real material, e.g. IA reference materials, secure suppliers of reference traces, new reference traces. And these are all areas I feel that NPL can take a lead. Now, I'm going to cover some of the ground that's already covered by Julian, so sorry for the boredom. But of course the NPL and the community have not been idle, they've not been unaware of this issue. To give you some idea why reference materials are important, recently we were looking at the high temperature detritiation of desiccant waste from the reactors. This is aluminosilicate. You couldn't get a more simple matrix. And indeed, we thought the analysis would be quite straightforward. But from the data, it was quite clear that it was anything but. And there were quite significant matrix effects with regards to chlorine-36 and carbon-14. Now, that was unpredicted and shows that yes, we do need some reference materials. We can't rely on in-house reference materials to give us confidence. Now, of course, this is nothing new, and in 2005, Julian and Simon Jerome went around all the users and came up with this report identifying what we did, where we did it, and what we needed. So as you can see, concrete was very much prevalent in people's minds at that time, 2005, followed by soft waste, soil, steel, brick, graphite, all the usual decommissioning materials and quality materials. Interestingly, at the time, tritium was top of the league, principally because it was at that time with difficulty in measurements and its mobility. So although one could quite happily gamma spec concrete, if there's tritium present, it was less easy to discern a confident fingerprint that was going to be stable across the entire waste stream. Then we had the workshop, 2005. And again, this is exactly the same table that Julian produced. Thanks, Julian. But again, the priority materials were concrete, steel, and soil. Tritium, because of its mobility, carbon-14 actinides. Sample size, we're talking about 500 grams, and the activity range was about 0.4 becquerels per gram, 1 to 2 becquerels per gram steel. MPL researched this requirement, and they did indeed prepare some reference materials. One was a tritium in concrete, which was subsequently placed into an intercomparison campaign, and the results that came back, I think Julian will concur, demonstrated some variability. Now, whether this was down to the preparation of the reference material or the analytical techniques is a moot point, but nonetheless, it demonstrated the need. Arvik has been looking at an activated metal as well. However, it's not really that straightforward. For certified reference material, you're looking at choosing a realistic material. Well, just how do you do that? You have to choose a test material, you have to characterize it, say, for a metal, for activation, precursors. You then have to consider the nuclide speciation to match that prevalent in the waste itself. You've then got to look at stability. And all this leads to very long lead-in times, and we're not getting any younger chaps. And it's very expensive to actually realize these materials, in my opinion. I mean, realistic material. Now, these are some pictures from an earlier presentation I gave at the NPL SUF meeting about 2 years ago now. And this is magnet sludge. It's a little blurry, but you can see the variability in composition. I think Jasper will recognize these pictures. At the top right, yeah, I thought you might. At the top right-hand corner, mostly sandy, granular, all the way down to a glutinous gloop at the far end. I mean, trying to ascertain a realistic material to match magnet sludge, and let's face it, magnet sludge is one of the red flag characterization challenges at Sellafield, as well as at in Magnox, is going to be difficult. So, is it time to consider a different approach? What I tend to think of as consensus certified reference materials. I take a leaf out of the environmental community, where for years now, IAEA, for example, have generated Pacific seagrass ashes, milk ash, soil ash, etc., which have been characterized through consensus analysis by a number of government laboratories, which people can use to not only test the methodology, but use on a routine basis for proficiency testing. That was the original idea. However, there's not very many around now. If I just digress a little bit, and those materials are becoming very, very valuable to the point where they cannot be used for proficiency testing. They're just too valuable. That's another issue. But could we take that approach and apply it to nuclear decommissioning? Could we take real wastes, process them, NPL perhaps provide metrology oversight, and create these CCRMs for the nuclear industry? Again, it's nothing new. NPL have been looking at this in the clearance and detection field, and they have generated a silicate standard and a concrete standard. which is great for clearance exemption, but is, of course, we need something with high levels of activity to truly test the analytical management process inherent in the analysis of high level LLW and ILW in particular. The advantages, it's quite straightforward really. You have a realistic radionuclide speciation. It's a real material, so matrix effects, whether unforeseen or not, will be taken into account. They're stable. I mean, they're actual weights. They're sitting in the tank. They've been sitting there for ages. I mean, fairly unchanging, relatively. Tritium will always be an issue. Shorter lead time than creating a traditional reference material, possibly. And possibly a more reasonable cost, because we have to remember that whatever material we generate must be usable, must be affordable. There's not much point creating a reference material that's going to cost £1,000 a gram. It's got to be usable. So what next? Well, again, apologies for the brevity. No pretty pictures, no animation. But that's the essential message today. In the syndicate this afternoon is to reaffirm the preferred materials for reference material. Concrete, is that still an issue? Steel, is that still an issue? Oil, is that more of an issue now than it was 5 years, 6 years ago? Graphite, is that less of an issue now? Now we've got a more confident idea of what we're going to do with this stuff. The preferred activity ranges. From the previous table, it's very much focused on clearance exemption, less than 0.4, and around about 100 becquerel range for things like activated steels. Things have moved on a bit since then. Can we please think about what your preferred activity ranges are? And then your view on CCRMs versus CRMs. Are you happy with this approach? Do you think this is relevant? Do you think this is reasonable? But also, let's not forget the other side of the coin, which is the need for a secure supply of radioactive traces. Calcium-41 has always been a bit of a question. Plutonium-241, I know that's addressed, has been addressed since, but nonetheless, security of. And more recently, the shattering news that QCY48 will disappear from the shells, in which case, do we have a replacement for that? Is that being lined up? And of course, any other issues, any other business which you feel needs to be addressed now or in the near future, concerns that you have with regards to improving the underpinning metrology in analytical measurement for nuclear decommissioning wastes. Well, that's it. And if you've got any questions, I'll be delighted to take them now briefly. But what I want you to do is think about these issues, and so we can have a good discussion this afternoon.